Welcome to another deep dive. You ready to go?
Always.
Awesome. So today we're going to be looking at something kind of interesting. It's going to be about temperature.
Okay.
Yeah, but like from the old school thermometers that we all grew up with, like
Yeah.
to like smart devices that monitor our homes and stuff,
Okay.
like a big jump.
Huge, yeah.
Yeah, but it's interesting because there is that connection between those old mercury thermometers and the modern tech that we have today.
Yeah, well, it's interesting to me how something like measuring temperature,
Yeah.
which we take for granted,
Yeah.
has had such a huge impact on our scientific understanding of the world.
Oh, yeah.
Yeah.
I mean, if you think about it, like our ability to like measure temperature accurately,
Yeah.
like completely revolutionized fields like thermodynamics, and stuff.
Yeah, and it was critical to the development of technology,
Totally.
like the steam engine.
Yeah.
Yeah, so it's pretty fundamental.
So like taking it back old school, right?
Yeah.
1709, Daniel Gabriel Fahrenheit invents the first mercury thermometer.
Wow.
That's where we get the Fahrenheit scale.
Mm-hmm.
And this is something I didn't know until I started reading the research for this.
Yeah,
Like the Fahrenheit scale actually predates the Celsius scale.
that is interesting.
I know. I thought Celsius came first.
Me too.
But nope.
Learn something new every day.
But then later, in 1742, Anders Celsius comes along, and he develops the Celsius scale, which, as we all know, is kind of the standard in most of the world today.
Right, because it's based on the freezing and boiling points of water.
Right.
So it makes a lot of sense.
0 to 100.
Exactly.
You can't get much easier than that.
Yeah.
But let's talk about the thermometers today.
Okay.
I mean, like, we've come a long way.
Oh, for sure.
You don't just have those old mercury thermometers anymore. We have all sorts of thermometers.
Yeah, I've got digital thermometers.
Yeah.
We've got infrared thermometers,
Yeah.
which don't even require contact,
Mhm.
And they use lasers or infrared radiation to measure temperature from a distance.
Oh, yeah, those are super cool.
Yeah, and probes for all sorts of uses.
Yeah, like for cooking and for science experiments and all sorts of stuff.
Oh, absolutely. And for like healthcare professionals,
Yeah.
all sorts of things. It's just a much safer and more user-friendly experience.
For sure. And like imagine, like you were saying, no more mercury spills.
Right.
I mean, mercury's like kind of a scary thing.
Yes, it's very toxic.
Yeah. So it's much better to have something digital or infrared where you don't have to worry about that.
Exactly.
Okay. Well, we've talked a lot about thermometers,
Yeah.
but our deep dive
Yeah.
also goes into monitoring devices.
Right.
So like these are those electronic devices that watch and record things over time using sensors.
Right. And they are really kind of like giving our homes and our devices senses.
They're smart. They're like little robots.
Yeah.
Yeah, so think about the motion detectors in your home security system or how your fire alarm senses smoke and temperature increases.
Yeah.
These are all monitoring devices. And temperature sensing is actually often the core of how a lot of these things work to keep us safe.
Right. It's fascinating how it all comes back to temperature.
Yeah, it's pretty incredible.
Yeah.
But how do they actually, how do they do it?
Okay, yeah.
Like, how do these things work? Well, our sources mention a few terms that help explain it. One of them is sensor, which is pretty straightforward, I think. Like a sensor is just a tool that detects changes, right?
Yeah, basically.
But then they also mention this term Boolean,
Right.
and that one I had to look up.
Yeah, that's a little more technical.
Yeah, it was a little tricky, I'll be honest.
Yeah, it is. But it's actually really crucial for programming how these devices make decisions.
Okay.
Okay, so imagine it like a simple if this then that system, okay, with only two options, true or false, 1 or 0.
Okay.
Okay, so let's take a fire alarm as an example.
Okay.
Okay, so if the temperature sensor reading goes above a certain threshold,
Mm.
that threshold, by the way, is called a variable.
Okay.
It's a value that can change.
Okay.
So if the temperature sensor reading goes above a certain threshold and D, the smoke detector is triggered,
Yeah.
then the alarm activates.
Okay, so that makes sense. So Boolean is kind of like the logic, the true or false, and the variable is the number that can change that sort of tells the device what to do.
Exactly. And it's really powerful because it allows these devices to take in all this information from the sensors,
Right.
analyze it,
Yeah.
and then make a decision about what action to take.
That's so cool. Like these things are thinking,
In a way.
but obviously they're not actually thinking, but they're following instructions
Right, exactly.
that are based on these sort of like logical statements.
Yeah, it's really clever.
So we've got the sensors, we've got the Boolean logic,
Uh-huh.
but there's also this emphasis in the sources on these devices needing to be reliable.
Right.
And that's where words like durable and water resistant come in.
Yeah, those aren't just random features.
Right.
They're actually really essential for making sure that these devices can function correctly in all sorts of environments.
Yeah, I mean, think about like a smoke detector.
Yeah.
You want that thing to work, whether it's, dusty or whether there's humidity or whatever.
Absolutely. Or like a thermostat.
Yeah.
It needs to be able to withstand changes in temperature and humidity and all that.
So it's not just about like having the fancy sensors and the programming.
Right.
You also have to build these things so that they can last,
Right.
so that they're reliable, and so that they can actually do what they're supposed to do.
Exactly.
It's kind of like you're building for all these different scenarios.
Exactly.
Okay, well, we've talked about durable, water resistant, and there's also this term that comes up, synthetic,
Right.
which kind of reminds us that all these cool devices that we're talking about, they all rely on human-made materials.
Yeah.
They're not like, made out of wood or stone or something like that.
Right. We're talking about plastics, we're talking about metals, we're talking about all sorts of specially engineered materials.
Which is kind of a testament to how far we've come in material science, I guess.
Absolutely, yeah. Material science plays a key role in making all of these sensors and devices possible.
Totally. I mean, we couldn't have these things without the right materials.
Exactly.
The other thing that I thought was kind of interesting in the sources was this mention of workplane, specifically workplane CAD.
Oh, yeah. That might seem a little out of place.
Right, because it's like, what does that have to do with temperature and all this stuff?
Yeah. But it actually highlights the design process behind these technologies.
Ooh, okay.
Yeah. So workplane CAD refers to computer-aided design software
Right.
that engineers use to design and model all these devices in a virtual 3D space.
Okay.
So whether it's a tiny temperature sensor in your phone
Yeah.
or a huge industrial monitoring system,
Yeah.
engineers use CAD software to model and optimize these devices to make sure that they're perfectly suited for their intended application.
So we've got like this huge range of technology that's being influenced by temperature and sensing and monitoring.
Yeah.
It's like we've gone from, simple temperature scales to these like really sophisticated systems that are monitoring all sorts of things around us.
Yeah, and it makes you wonder how this is all going to impact our lives even more in the future.
It's a little mind-boggling.
Yeah, it is, but it's also really exciting.
Yeah, totally.
Like imagine how advancements in AI and sensors could change the way we interact with our environment.
Yeah.
Like what if we had systems that could anticipate our needs based on temperature changes in our home or outside?
Yeah.
Or these ultra-sensitive networks that could monitor for even the slightest changes in our surroundings and alert us to potential problems or hazards.
Right. Like before we even know something's wrong.
Exactly.
Yeah, that's super cool. But like, I also have to wonder about the privacy implications of all of this.
Right. I mean, as these technologies become even more integrated into our lives,
Yeah.
it's definitely a question worth pondering.
For sure. So we've gone on this journey from the invention of the mercury thermometer in 1709
Wow.
to like the mind-blowing potential of AI-powered monitoring systems in the future.
It's pretty incredible when you think about it that way.
It's a lot to take in.
It is.
So we'll leave you with this final thought.
Yeah.
How do you envision these advancements shaping our future?
Yeah, what are the possibilities?
Yeah, what are the possibilities and the challenges that you see on the horizon?
Right.
Thanks for joining us for another deep dive.
It's been fun.
Yeah, this was a good one.
It was.